In this clip, we are going to solve a couple of problems from the slides for the test of independence, chi-squared test for independence, chapter 12.2. Okay. What I've done is I've copied over the slide with the crime data on it, and then I've typed in to Excel cells the relevant the data itself. Okay. Now we're going to run through this, and we'll go through the 6-step process. So we have an HO, we have an HA, so we have our step 1. Our HO is simply that the variables, right, and we name those variables are independent versus they're not. So the variables age and crime, or crime and age, are independent versus the variables age and crime are not independent. Okay. Alpha stated as we usually go with this. So alpha, and let's make alpha 0.10 in this particular case. Step 3 is now we're going to worry about the chi-squared test statistic. And the p-value. So these two are related to each other. And so we'll find the p-value, we'll use that p-value to find the test statistic. It's just easier to do it in that order. The first step to this, and I'm going to use Excel for this, is I'm going to make a copy of my table. Oops, let's make that copy. Control-C, Control-V. I'm going to get rid of all the observed values. Okay. I need the column and I need the row totals, but I don't need the observed values. Now I'm going to come up with the expected values. Now I look in the slides and I see the expected values are essentially equal to the row total times by the column total divided by the complete total. Okay, so that gives me the expected values for one cell. Now I really don't want to do this 12 different times, so I'm going to use the power of mixed referencing in order to kind of reduce my workload a little bit. So I noticed that I want to be able to copy this cell across and down. So when I copy it down, when I look at the row total, I want the row total to also go down, but I don't want it to shift to the right when I copy this cell to the right. So what I want to do here is I'm going to push the most powerful key in Excel, the F4 key. Right? And I'm going to put some dollar signs around the column, because I don't want the column to change, but I do want to keep the row relative reference. It's called mixed referencing. So I've got the dollar sign in front of the G, but no dollar sign in front of the 30. I want the row to change, but I don't want the column to change. Same kind of thinking when I look at the column total. And I push that all-powerful F4 key again, and I want the column to be locked in. So I want that dollar sign in front of the column, but I want to be able to, I want that dollar sign in front of the row, but I don't want, what I don't want is to lock in the column. Okay? And then for the 750 number, that's absolute reference. That changes for nobody. Okay? Once I've done that, I can then take that particular cell, copy it across, and then copy it down. Right? So it's very, very nice, very convenient that way. Saves you and me a lot of work. Okay. So now I can go to that chi-squared test statistic, or sorry, the p-value, and equals to chi. Now, I mean, in the old days it would be a chi test. Boy, that was simple and easy to write. Now it's chi-squared dot test. Like that makes things a lot better, but I'll double click on that and use that anyway. So the actual range is our observed values. So I copy all our observed values, a comma, followed by the expected values. Okay. Don't include any row or column totals. Close that bracket, and it is easy as that. Push enter, I've got the p-value. Nice, very small p-value. I'm going to use the chi-inv function. Right? Probability is that p-value. and then I enter in the degrees of freedom. I remember that the degrees of freedom for this particular test is r minus 1 times c minus 1. I have 4 rows, minus 1 means I have 3, times by, I have 3 columns, minus 1 is 2, 3 times 2 is 6. Close the bracket, and there's my chi-square test statistic. I am just going to note that the degrees of freedom equals to 6, because of course no chi-square test statistic is complete without noting the degrees of freedom. So what can I conclude with this particular p-value? Well, now we roll into decision 5, which is the same as always, right? Decision 6, which just follows from the decision 5 in the usual way. I'll leave it up to you to put in the details on that. At this stage, I think we're pretty solid with how decision 5 works. Let's roll with the second example in there. So we have a manufacturer of sports drinks has a random sample of 198 men, 202 women. Each sample participant was asked to taste an unflavored version and a flavored version of a new sports drink. Preferences as below. Okay, so again, like we did before, I've copied over the data into Excel, and I'm just going to, for this time, there was no row totals in there, so I'm going to use like the sum function just to sum up these numbers. Okay, and I close that bracket. Push enter, and this way I can copy this down. I can copy it all the way down. Okay, let's continue. One of the interesting things about doing lectures on YouTube is that the world continues on even though you're recording. So just finished doing up some, putting away some groceries from Walmart. Of course, this is being taped at the COVID-19 outbreak. As much as everyone says it's kind of silly to hoard toilet paper, you still can't buy toilet paper. So it's kind of funny. So let's continue on with our example here. So we have our HO and our HA, just like we had in the previous question. And same kind of idea. Okay, the variables, what? Gender and flavor preference are independent. Again, versus the variables flavor preference and gender are not independent. Okay. Alpha we see is given to us in this particular case, and so 0.05. And now it's up to us to do the chi-square test statistic and the p-value. As we did in the previous example, we're going to make a copy of our data set. Want to get rid of the observed values, and we're going to calculate the expected values. Oops, sorry. Let's just keep it real. I'm going to make a paste of just the numbers. Sorry about that. And then we get rid of the observed values. And just like we did before, we're going to calculate up the expected values. So row total, again, I'm going to lock in that column, times by the column total, and I'm going to lock in that row, divided by the total. I'm going to lock in everything. And push enter. Copy that across, copy it down. I've got all my expected values, nice and easily. The p-value is what we'll calculate first. Okay, and we'll use that chi-square test function. Actual range is the observed values, comma, the expected range, which is what we just calculated right now. Okay, and it's as easy as pushing enter. We get the p-value, then we'll use that to find the chi-square test statistic. So it looks like we're looking at a pretty small p-value, so you know what that means. Then we'll use that chi inv function. Whoops, forgot the extra I. Gotta love it when it's live. And then the probability is just the p-value, and the degrees of freedom. This one's nice and easy. 2 minus 1 times 2 minus 1 is just 1 times 1. 1 times 1 is 1. Close that bracket, and I got the chi-squared test statistic. I make a note that the degrees of freedom is equal to 1, right? 2 minus 1 times 2 minus 1 is 1 times 1 is 1. And again, I use that p-value. Step 5, use the decision rule. What conclusion do I make? The variables are independent or the variables are not independent. And I leave the rest to you.